Welcome to the Engineers Hub podcast, where engineers come to connect, learn, grow, and get inspired. On every episode, we will be interviewing engineers, managers, technical experts, and industry leaders from various disciplines to share their stories and experience, uncover various engineering career paths, and inspire engineers to do more and be more. This is your host, Mamadou Jallo. Let's get started. Hello, and welcome to another edition of the Engineers Hub podcast. We are here today with our guest, Edwin Quinn. How are you doing, Edwin?
Doing great. Really excited to get on the podcast and talk about some engineering stuff.
I am excited as well. I always like to begin with gratitude. First of all, man, thank you for coming on here. I appreciate you taking the time and putting other things away to come here and join us and share what you do. And I know the cool stuff that you've been seeing and doing over your engineering career. Do
Of
you
course.
Can you go ahead and maybe introduce yourself and you tell us a little more about what you do?
Sure thing. Yeah. So I'm a mechanical engineer. I started out about 5 years ago while I was still in college with an internship. And so basically, I have 3 years of full time experience and 2 years of internship experience within the defense industry, working mostly with microelectronics and other types of electronics hardware engineering. Um, so this utilizes all sorts of mechanical engineering topics from vibrations, heat transfer, solid mechanics, design, CAD, drawings, all that kind of stuff is used at my job. So it really covers the broad spectrum of topics that we study as mechanical engineers. It's also very hands-on, so I've gotten a lot of manufacturing experience, which is really fun. But yeah, I really love the industry. It's been really nice, and the last 5 years of working, and actually I've just completed my master's degree this last fall, so December 2020. So I'm finally out of school, but it's been really fun to transfer a lot of this academic knowledge into industry and be able to apply it to like real life projects. So basically that's what I do, and we can get into some more details of aspects of the industry and my job as we discuss here.
All right. Well, first of all, congratulations on getting that master's out of the way.
Yeah,
Um, did you?
thank you.
You're welcome. Did you know? I guess was there anything that influenced you to pursue your master's? Because for me, one thing I've been struggling with, I've pondered upon it. I'm sure like anybody who has graduated right with their bachelor's degree, but sometimes you're like, I'm not really sure what to even master in, or if I want to pursue in, what I studied in undergrad. Did you experience that as well?
Of course, yeah. I mean, I had a lot of different ideas on what I might want to do for graduate school, ranging from all the way up to being a PhD student, all the way, maybe get an MBA. I didn't
Mm-hmm.
really know, so I really decided to do the Masters of MS in Mechanical Engineering. Almost, probably, I would say 80% because of Dr. Liang Zhu at UMBC. She really inspired me to do research in her lab. So it was really based around working with Dr. Zhu
Mm-hmm.
and completing the masters at UMBC because I had already met her in undergrad and she was really a big inspiration to me. I really had a big passion for heat transfer. So,
Mm-hmm.
I figured it's a local school and it's I can't really go wrong with learning more about something I already like. So that's kind of
Yeah.
why I chose it, and
Mm-hmm.
it was very convenient and close to my job and home, and I felt comfortable there. So I decided to go through with it. And if I wanted to do a different master's degree or some other exploration down the line, I can always do that too. But those were the main reasons I chose it.
That's true. Yeah, those are some good points. Did you, um, since you did it with her, was your focus on special transfer? Did you, or heat transfer?
Yep.
Yeah, I'm assuming.
So I did a master's focused in heat transfer in bio heat transfer actually. So Dr. Zhu studies how heat is transferred in the biological humans and
Mm-hmm.
animals sometimes to
Mm-hmm.
help solve medical issues.
Mm-hmm.
She solves everything from tumor mitigation to like studying how head trauma can be affected by heat transfer and all sorts of different things. So it's very interesting. my focus was actually on tumor mitigation using laser heat transfer. So
Hmm.
that was my thesis that I completed and defended last fall.
Nice.
Definitely more work than I thought it was going to be, but I'm really happy and proud that I completed it.
Yeah, it's really nice, and you know, she really makes it fun. And I remember when I was taking her class, she brought up, especially like the heat transfer in biological bodies. I feel like there's a lot of opportunities there because we still don't know
Mhm,
much about it. We know about inert objects, but we don't know much about the human body and how it
mhm.
interacts. And she was bringing points like, for example, for let's say firefighters, you want to give them a suit when they go in a hot environment. You want to give them a suit that's going to protect them from the heat, but also you don't want them, they need to cool off, they need to release heat as well, because otherwise they're going to
Right.
start suffocating internally as well. So it's really interesting and cool.
Definitely. It's almost unlimited how many different topics you can explore in bioheat transfer.
Mm-hmm.
And in fact, Dr. Zhu, her advisor at I believe it was a New York university.
Mm-hmm.
I'm not sure. Her advisor actually invented a lot of, or invented a lot of the models that we use today for bioheat transfer. So it's a relatively new area of study, and Dr.
Mm-hmm.
Zhu is really a forefront leader in the industry. So that really drew me to be able to contribute to something and also to be able to help directly humans is interesting in mechanical engineering because you might not normally think that it's gonna directly help like human life because we are more mechanically inclined.
Yeah, that's definitely true. But it's kind of surprising to me, especially if even our body is always trying to stay in homeostasis, right? And
Right. Hmm.
but if your body, even if it deviates by a few degrees from that 97.3 Fahrenheit, you actually
Hmm.
get really ill. So it's
Of
surprising to
course.
me that
Yes.
nobody has
The
ever
reason
considered.
and part of the reason for that is because here's something interesting that another reason I like this. I'm really into cars and vehicles and
Mm-hmm.
all sorts of other mechanical type things. The
Mm-hmm.
human body is like the perfect mechanical structure,
Mm-hmm.
honestly, because so your blood flow acts as almost like your coolant system in your car.
Yeah.
It cools the brain and heats
Mm-hmm.
up areas that are cold, further like
Mm-hmm.
your fingers and other areas.
Mm-hmm.
Almost all the mechanical systems you see in like real life are modeled after biology. So it's very interesting to like back up into the biological aspect and see how things actually were designed in nature. It's actually like a very good design. There's actually a whole industry on copying biological type mechanics.
Mm-hmm.
I know other professors study birds in flight and how their flow around the wings and stuff like that for applications with drones and planes and
Mm-hmm.
everything else. So nature really is a great teacher in
Yeah.
engineering. It's really interesting.
Yeah, and it's the best model example we have that is working. So when
Of
you're trying to
course, of
like,
course.
yeah, definitely. I
So
think
that's very interesting.
no, I was just gonna say I think any breakthroughs that we have in terms of understanding heat transfer and heat flow within the human or
Mhm.
biological bodies, I think is going to have great ramifications and innovations in terms of our lifestyle, as a society and everything. From
Of
airplanes, from
course.
how we design buildings, how we design homes, and
Mhm.
and how we make any apparel.
Of course. Exactly. I mean, yeah, in understanding how that's designed is good, but it's also helpful in treating and helping humans. For instance, like my thesis focused on treating tumors,
Mm-hmm.
and the goal is normally tumors are surgically removed. That's like a typical method of removal.
Mm-hmm.
My focus was using non-invasive treatment using lasers. So
Mm-hmm.
the laser would be like a source energy and
Mm-hmm.
heat up the tumor itself and kill it without
Mm-hmm.
having to do any surgery. Very limited side effects,
Mm-hmm.
and basically heat it to the point that it dies and is consumed by the body. So that would really help cancer patients
Mm-hmm.
be able to not have to go through a lot of this invasive surgeries and chemotherapies that they normally have to go through.
Yeah.
So as we push on in these topics, we can see how it directly helps limit side effects for surgery
Mm-hmm.
and everything else. So it's really interesting to me.
Mm-hmm.
Unfortunately, I don't really use what I studied in that a lot at work, which is fine. I mean,
Yeah.
I did it because I really liked it. I learned
Uh-huh.
how to problem solve well, but I don't
Yeah.
actually apply bioheat transfer at work at all.
Oh, well, I mean, I'm sure you can understanding of the concepts and the research you went through. I'm sure you may be able to indirectly apply that somehow
Hmm.
to your work. That's I think, I guess that's one of the things, because I'm even surprised to hear you actually, sounds like from what you said, you do use quite a bit of some of the knowledge you acquired through undergrad at your job, because
Definitely.
that hasn't been my experience in most cases. For me, at least, depending on the situation or certain context, I had to draw in, whether it was my first job designing couplings over there, we only cared about, things like vibration or machine design,
Stress,
when or
strain.
stress, strain, yeah, those concepts, and they were they were important, on a case by case basis. But most times we didn't have to really draw out of that knowledge. now
Yeah.
now that I moved to a project engineering role, I'm doing a lot more project management, but it's also, and I do a lot of drawing review and design review. I don't necessarily employ the knowledge that I acquired, but I do have to draw from it, because
Hmm.
sometimes I may look at things and see how loads are structured, and I may be able to catch things like, hey, this is going to fail, or hey,
Right.
there's a lot of vibration here. We need some kind of dampener, or hey, there's a design and no one understands what these are for. However, because of my experience, and I understand that, okay, this piece of material you hear, maybe nobody else understand, but this is supposed to be serve as a spring, to absorb load or stuff, things like that. So you draw it here and there, but I was quite surprised to hear that it seems like you do use quite a bit of what you acquired.
Of course. Yeah. So, the way I see it, there's a positive and a con to it. So because I'm using all these different topics like, heat transfer, vibration, all the stuff I mentioned before, a lot of the core basics of the engineering we study,
Mm-hmm.
because of that, I kind of need to have a working understanding of all these topics, and maybe not super advanced in any single topic. I'm not an expert in heat
Mm-hmm.
transfer and microelectronics. I'm not an expert in vibration
You might be
standards and
surprised,
all of
man,
that.
especially now that you
But
get your master's.
but I get to apply it all.
Mm-hmm.
Whereas someone like you, if you're designing couplings or something
Mm-hmm.
very specific, and you can become very good at it and applying,
Yeah.
a certain topic in engineering, there's something to be said for being an expert in one area. It really allows you to be very marketable and very, what's the word? You can be very productive in a certain industry if you're an expert in one
Yeah.
topic. We do have people who work at my job who are experts in heat transfer or a certain topic.
Yeah.
Personally, I like everything, and I like
Mm-hmm.
to be hands on with a lot of different things. So
Mm-hmm.
I enjoy having to wear many hats and applying different, bringing lots of different analyses together in order to create a design. So
Mm-hmm.
there's definitely pros and cons. And I mean, if I think, like you said, you're doing some drawings and design reviews. You do definitely have to have, like you said, a working knowledge and understanding in order to be able to know what you're looking at.
Yeah. Yeah.
But yeah, it's really up to the person. If you're really passionate about one area,
Mm-hmm.
then maybe that's better for you. Or if you're really just kind of generally interested in engineering, like me, it's nice to be able to just kind of apply lots of different types and be able to use lots of different types.
Mm-hmm.
So
Yeah.
that's kind of where I'm at.
Yeah. It's quite interesting, because even I remember, even going when I was working with couplings, one of the things
Hmm.
that I continuously had to keep in mind was in terms of just mechanics and materials, right? And how materials behave, or metals specifically behave
Hmm.
in various temperatures. The
Right.
product's gonna be used anywhere from a really hot area to sometimes some are being employed in the North Pole. Whereas
Negative.
negative, degrees, negative degrees. So you have to, though any material that you may be using, you have to continuously explore and consider whether or not this is actually a good fit, and you have to be
Of
able to
course.
catch that. And even now, moving away from couplings to just project engineering, project management, I still have to do that, because we may have a project, right, or that building, and they may the plan may be, especially you have a timeline. The idea may be, okay, we starting demo might be starting maybe in the timeline of January, right? And then we're gonna be replacing certain things or bringing in installing new things around summer. However, because of delays, the project just shifted for 6 months, and now we start in
Right.
the summer, and then
Winter.
yeah, and then now what was supposed to be in the winter happens in the winter, and in
Right.
that case, if you just still go with whatever was specified, it's going to fail on the field or during installation. So you have to be able to catch that and kind of always be on your feet because or on
Right.
your toes.
And
So
that's very interesting, and that goes across, I think, almost any engineering industry. And it talks about like the idea of having a set of requirements that you have to meet. In engineering school, we solve problems individually in different classes, and maybe in senior design, you might have some requirements that you have to meet. But in real life engineering, every single thing you do is based on some requirement by some customer. So like you said, is it being introduced in the summer or the winter? What's the environment? What's the goal? How well does it have to perform? And like following those requirements can be quite the challenge. And weighing which requirements are more important and less important becomes a huge thing in real life, because at the end of the day, we're trying to deliver a product to
Yeah.
our customer,
Yeah.
whether it's a coupling or something I'm designing.
Mhm.
And yeah, like you said, you have to think about all of the different trade-offs and what the engineering implications are. And that's definitely something that you will find in industry much more than I found in school.
Yeah.
So
Yeah.
I know a lot at UMBC, we were able to explore that in a lot of our design classes.
Mhm.
But I think I was a little bit surprised on how challenging it can be to balance requirements while also applying engineering knowledge. It's quite a balance. It can be challenging, especially when requirements change, like you said. Like
Yeah.
for instance, you thought you were installing in the summer, next thing you know, you're in the winter.
Yeah.
I thought
So
maybe my electronics design was okay at 70 degrees C, and now it fails, but it needs to go here. Like moving requirements are quite a challenge, but it's kind of fun. You have to be able to be flexible and sometimes be creative and innovative in order
yeah.
to meet requirements.
Yeah, and this is a tangent, but I don't know if you remember when Samsung there was a time when I don't know if it was Samsung phones, they started catching fire. Remember
Yes, it was.
remember
Yeah,
when
I
that
think it
when that
was.
happened? Yeah, and there was this big recall. And I
Right.
did you ever do you know why that was happening actually?
I know it was involved with the light pole batteries, I believe, or something.
Yeah. So
I think they were expanding or something.
yeah, exactly, because something that had to do with the pressure. So
Uh huh.
that component was actually, I think, being produced in Taiwan or something like that. So when they were actually shipping it over to the US, through airplane,
The
the
temperature. Yep.
yeah, the temperature changes and then it's going in the air, so the pressure, like the as depending on the elevation of the flight, the pressure
Yep.
changes, and then like it actually affects and causes some kind of pop in the component, and then when it's brought
Sure.
here, that's what was initiating it. That,
That's crazy. I mean, that's the type of thing that it's very hard to see into the future and prevent. And
yeah.
that's what our job is as an engineer, is to prevent those kinds of things, and try to do our best to cover our bases and design things around that.
Mm-hmm.
Luckily, in my industry, we have something called, like, we have EOS and ESS testing, which we'll design something and we'll put it into EOS test. It's basically environmental stress testing,
Mm-hmm.
and that puts it through all sorts of temperature, shock, vibration, electrical shock, all these different stress tests to verify that it's like a reliable product. And once it's through that, we can kind of be pretty confident that it'll be okay. So
Mm-hmm.
we that's our main metric. But yeah, it's very interesting. Like we there's a lot of things you can't
Yeah, you could
foresee.
not foresee, definitely,
Right.
because how can you guess what kind of mode of transportation this could be, or where it's going to be transported, things like that.
Exactly. And you might want to think about the temperatures, but here's the thing: when you're a company like Samsung or an Apple, or really innovative, cutting edge consumer product designer,
Uh-huh.
you're trying to make things as small as possible and as
Yeah.
advanced as possible to stay up with the market. So and get them to market as quickly as possible, because that's how you make money.
Yeah.
So they have the smallest, the fastest, the best battery, all that stuff, and they
Mhm.
want to get it out to the customer as soon as possible.
Mhm.
They probably, not that they overlooked it, but with that challenging engineering, you're going to want to just get it out there as fast as possible, and you might not be able to. You might not even have time or money or resources to think about like, oh, are we going to have some weird pressure, temperature change when we ship these things or not? So it's definitely a challenge for the consumer industry that that you have to get around. Whereas some more industrial industries, you might have more time to do more analysis.
Yeah, definitely, definitely. So I didn't ask you this, but what sparked you, or what sparked you to really actually even major in engineering and even mechanical in the first place?
Sure. Yeah. So if you go back, I mean, in high school, I wasn't the best student. I would be C student. One thing I was good at was math. I liked math always, and I always had a passion for working on cars, mechanical things, putting things together, building things. I just always have liked that. And I got to college, UMBC. I actually started out as a business major because I thought I wanted to be a business person. I'm still interested in business, actually, kind of, but. And everyone told me engineering is so hard. Mechanical engineering is so difficult. It's really a huge challenge. Like, you might fail the whole thing. And I didn't really have anyone saying like, oh, you can do it. And so I kind of just made the decision like, it's okay if I fail. If I fail engineering, at least I tried. So I signed up for ENES 101. And ever since then, I never looked back. And I just, I gave it my all. There's some classes where I was like, I don't know if I'm going to pass. And I just kept pushing and, I passed, and I even went on to get my master's. And I think if you have a passion and a drive for engineering, you don't have to be the smartest person in the world. You can get through it. And if you like it enough and you put the work in and you have a good group of people that, share the passion to study with, you can get through it. I think I encourage people to go into engineering now, because I think it's somewhat, people see it as something that it's not. I think people think it's harder than it might be. Granted, it's not easy. It's definitely challenging. You definitely have to work hard. But
Yeah.
I think if you put your mind to it, I think I think a lot of more people than people give credit for can be engineers. And I think it's really important for the future that more people get into it, especially underrepresented groups like minorities and women. I think all the initiatives to get them involved are awesome. I think we should do more of that. I've even found at my work it's not as diverse as it should be, and I think it's part of the stigma of being an engineer is like, oh, it's this this club that's super hard to get through and get into.
Yeah.
And it is hard. It's not easy. It takes a lot of work, but I think more people can and should be involved than there are now.
I agree. I agree. Like you said, the topic is definitely intimidating, and I think because even me, honestly, that's what drew me into it. When after I graduated high school, I had no clue what I wanted. I even didn't know engineering was a thing. Honestly,
Right.
I wasn't exposed to it. So it was when I went to community college my first year, I just took general studies and started exposure. And then I heard of engineering and I heard how challenging it is. So for me, it was of, hey, if this is hard, if you can get through it, you can get through anything. It doesn't matter.
That's a great. I mean, I kind of am the same way in life. I like, I ran cross country and do all sorts of kind of different outdoor extreme sports, and it's the same thing. You try something challenging and it builds your confidence. I mean, as I went through engineering, I got more and more confident in my abilities, and even with the low. I mean, most people have failed at engineering tests in school, and
Yeah.
you feel bad. I mean,
Yeah.
not everyone can do well in everything. I mean, maybe some people, but and you learn to work through failure. That's a huge thing I learned in school, was like working through failure and keep pushing and never quitting is are invaluable lessons. And I think engineering is a way to show you that like it's okay, and as long as you keep trying, you will succeed. And that's been true for me, and I've been really blessed to be able to learn those lessons and try to pass them on to others. So it's been really a great experience. I don't have one complaint about it.
Yeah, I definitely agree with that as well. And um, even if you don't, even if you're not directly using the knowledge you may have acquired, right? Like just that mindset that you acquire, like it's okay to, you can fail and get back on your feet and try again, right? And
Right.
the amount of stress involved, it kind of allows you to be able to handle more and handle life's challenges, no matter wherever
Oh,
you go to.
yeah, I totally agree. I mean, when there was some time in grad school when I had a real project at work that was due, like something for our customer, my
Mm-hmm.
boss, we really had to get this project done. But
Mm-hmm.
I also had a continuum mechanics exam
Mm-hmm.
and that same week and a project due for product development and everything else.
Mm-hmm.
And, you do what you can do, you do your best, and you learn that you can get through things and do more than you even thought you could. And a big part of it, I think, is leaning on classmates and coworkers and communicating
Definitely.
where you're at. If you do that, I think if you can communicate and
Mm-hmm.
and rely and lean on others, you can be very successful. I don't know a single engineer who's been isolated on his own and done everything that he's wanted to do. You really do. It's a team sport. I think engineering is definitely a
Definitely.
team sport.
Definitely. Yeah, I have to restate that it's a team sport, and not many people go through engineering school just on their own without like relying
Nope.
on the knowledge of friends, or like the
Hmm.
understanding of certain concept, because most of us have strengths and weaknesses. Like we have areas, some of us are really good like in fluids and that sort of topics and vibration. Others may be more so good in machine design and mechanics and materials and
Exactly.
statics, and thermodynamics. You kind of share, you share and learn from each other,
Of course,
and
it's
that's how you get through it.
collaborative,
Yeah.
and you're not expected to be an expert in every area, and that's okay. And
Yeah.
it's actually a very rewarding when you can work in a highly functioning team, whether you're studying for an exam, doing a project, or at work, and you have, I get to work with engineers who are electrical engineers,
Mm-hmm.
structural, RF engineers, radio frequency engineers,
Mm-hmm.
and just seeing them in their own worlds is just, there's a lot of overlap in a
Yeah.
sense that they use the same basics, but
Mm-hmm.
they're in a different world of engineering. It's very interesting, and being in engineering, you can kind of understand where others are coming from. It's really, like we said, it's a team sport, and what we say here at work is it's never good to engineer something inside a vacuum. You always want to be bouncing your designs, have design reviews,
Mm-hmm.
discuss your analysis with others to see if you missed something,
Mm-hmm.
and having that feedback is, like, I would say, almost essential to having a successful career and a successful projects. And I'm glad that they emphasize that in undergrad. I mean, we did a lot of group projects. I know
Mm-hmm.
everyone complains about group projects
Yeah.
and working with others because
Yeah.
a lot of times you feel like you can do more work
Yeah.
than others or whatever. But I will
Yeah.
say, in real life, a group project is pretty well representative of a team.
Yeah.
You really do need those skills, those communication skills, those collaboration skills in real life. So, and who said it's the worst thing in the world if you're doing more work than the other people? Maybe you're going to learn more then.
Definitely.
It
And
it'll it all pays off in the end. I'm telling you, like,
yeah.
you may feel like every single thing you go through in school, will pay off in the end. You'll learn something from it. You'll be a better person. You'll learn to work harder, get through more adverse things. Maybe not directly, but indirectly. I feel like I didn't waste a single amount of effort in the last 5 years of
Mhm.
what I've done. So
Yeah.
I would
That's
encourage anyone to continue.
yeah. It's definitely and I think I do think it was a good thing that they didn't always let students choose who they want to work with, because in the real
Exactly. Yeah.
world setting you don't really get to choose who you're working with.
Yeah.
You know.
I know. I remember. I think Dr. Rothman would maybe. I think it was machine design. He kind of assigned us groups, and
Yeah.
he said, "Hey, when you're in your real job, you don't get to hand pick your team,
Yeah.
and you got to take what you get and make the best of it." And that's definitely 100% true.
Yeah.
And it really does teach you, hey, you have to be a little bit humble and have some humility in your
Mm-hmm.
team,
Mm-hmm.
and listen to others' ideas
Mm-hmm.
and work with other people. Is, like, I would say that's, aside from the hard engineering knowledge and skill, that's one of the most important things in engineering.
Yeah, definitely. Machine design and also capstone. So yeah.
Capstone, we were able to pick our group, so
Wait,
that was
were
a
we?
little. I was able to. I'm not sure if you were. I
No,
was able to pick a group, and I had a really, really nice group. We had a great time.
oh, actually, I think we did pick our groups. Yeah, you're right.
Yeah.
We did pick our groups.
So we were able to do that. Capstone was definitely an interesting group.
Yeah, definitely interesting class, and the amount of, I guess, the scope of what was expected of you was really like industry standard, you know. So that was
For
really
sure,
good.
yeah. And I'll say that, you know, doing capstone where we went from the concept to the design to the design review to actually building and delivering a product,
Mhm.
that full life cycle of engineering is really invaluable in real life. A lot of the projects I do now have 6 months, so a little bit longer than a semester of capstone, but tight,
Mhm.
a tight project where we go from here are our requirements, let's get the design done, and then literally deliver a functioning, reliable product within a few months.
Mhm.
So and that's kind of what I enjoy doing, because you kind of are able to do a lot of things
Mhm.
quickly. It's really fun. Short-term projects. I know there's a lot of engineering in the world where the projects are a lot longer term and bigger
Mhm.
scoped, and
Yeah.
that's interesting and very cool too. But being able to deliver something that works in a short
Mhm.
time is pretty rewarding to me. So I really do enjoy the nature of that kind of work, which we kind of did in undergrad.
Yeah. So you right now pretty much you're very involved, or you're just mostly involved in the product development.
Right. So what we do at my job is we do develop products, but these
Mhm.
products are really low volume, so usually 20 or less, and they have really
Mhm.
specific requirements
And they
that
usually
some
are they components of like a bigger thing,
no. So
or standalone?
we do some of that. We do some space structures that are smaller components of much larger structures. But what I'm
Mhm.
really focused on
Mhm.
are they're all in one products that
Mhm.
do really specific things. Um, very highly specialized microelectronics. The industry I'm in is pretty small. It's government contracting.
Mhm.
But I have a lot of people at my job who have been in this industry for a very long time, so I can kind of use their knowledge and their leadership. A lot of them are now project managers and
Mhm.
leadership positions.
Mhm.
So the younger slash mid level engineers like myself are able to learn and build upon what they've already kind of set as the standard in our industry. So it's definitely neat. But basically, what we do is microelectronics, software-defined radios, which are small communications devices.
Okay. It's,
Yeah.
it's really nice and very very niche. That's I mean, I feel like everything, our whole entire world in terms of technology is shifting towards smaller electronics that are able to do more. So,
Yes, it's true, and it's funny. The leaders in it are definitely the ones you think of, like Apple and Samsung. Like we said,
mm-hmm.
they know they can spend the millions of dollars in R&D to get things extremely small. I mean, if you look at the iPhone's evolution over the last 15 years, from 2006 to today,
Yeah.
and what it's capable of doing, it's
Mm-hmm.
actually insane. The level of innovation and design and what they can do in such a small package
Mm-hmm.
is absolutely crazy. I mean, the miniaturization of this. I mean, your cell phone is as powerful as a computer was,
Yeah.
like 10,
Def-
15 years ago. So
Absolutely.
it's really, really impressive. It's really fascinating and interesting stuff. And we try to levy like industry stuff like Apple and Samsung into our products
Mm-hmm.
to serve the government.
Mm-hmm.
And sometimes certain things we have are a little bit more advanced, and certain things that they have are more advanced.
Mm-hmm.
And it's really a neat thing to be involved with. I'm really basically got lucky to get into this industry in a sense. I was at the UMBC Career Fair, and
Mm-hmm.
they had an internship opening. I actually started at this company when I was 19,
Oh wow.
and I've worked here straight through ever since because it's been so much fun.
Mm-hmm.
So it's been about 5 years right now, a little over 5 years.
Okay. So I was actually gonna ask, how did you get in this, and was it kind of
Mhm.
um, what you started off doing 5 years earlier? Is this is
Yeah,
what you started off doing,
sure.
or sort of?
So when I signed up for mechanical engineering, I guess my goal was to be designing cars.
Mm-hmm.
That's a lot of mechanical engineers want to design cars.
Yeah.
Cars are cool. Everybody has a car.
Mm-hmm.
You know, maybe even making sports cars. Something that sounds fun, and
Mm-hmm.
that definitely is a fun industry. And I probably would have had a very rewarding career if I had gone down that path.
Mm-hmm.
Um, but living in Maryland, there's not a lot of car design jobs, or a lot of them are in Michigan in the U.S., where
Yeah.
the big three are.
Mm-hmm.
So there wasn't really a lot of opportunity for that, and I got this opportunity to work at KeyW, which is a small defense contractor in the area. Literally, it's 20 minutes from UMBC, maybe
Mm-hmm.
18 minutes
Mm-hmm.
up 195. So I was able to work at an internship while going to school, and
Mm-hmm.
it was like super convenient, super easy, and the stuff we were doing was really interesting, and I could tell immediately that they had some of the smartest engineers that I'd ever interacted with, and very smart people that were pretty encouraging and inspiring. So I was really excited to be able to get this internship,
Mm-hmm.
enough that I worked like 20 to 30 hours a week in undergrad here, just because
Wow, that's
I enjoyed
impressive.
it. It was a
Mm-hmm.
lot of fun.
Yeah.
And I would rather work doing engineering stuff than I used to work on a farm, than working on a farm, or like
Mm-hmm.
at Chick-fil-A or something.
Mm-hmm.
So I was
Yeah.
really lucky and glad to have this opportunity. I've
Yeah.
just kind of stuck with it ever since.
Yeah. Do you think, I guess, because what you're doing also, it seems like it really does require a very good understanding of certain topics of engineering,
Hmm.
Do you think when you came in as an intern, you were very well understanding of that? Did you pick it up, through the internship, and then you were kind of ready?
For sure. So when I came in, I mean, I really had, I had taken mechanics of materials. I hadn't taken like heat transfer or vibrations yet.
Mm-hmm.
And so I definitely felt like a fish out of water when I
Mm-hmm.
started here. And luckily, our interns and the younger people who start here, they're not really expected to complete like highly advanced analysis work yet. So it's
Mm-hmm.
more, manufacturing, how to run the equipment,
Mm-hmm.
looking at drawings, doing a little
Mm-hmm.
bit of CAD work. So we really tone it to the level of the engineer.
Mm-hmm.
But I definitely saw when I came in people who are a little older, maybe 5 years older than me, doing really cool, applying really nice advanced engineering topics. And I thought, I was excited to get to that point,
Mm-hmm.
um, through school and experience here and mentorship and all of those things. So I definitely felt at first definitely very intimidated and stuff. But as with anything, if you stick with
Mm-hmm.
it and you learn, you
You,
can get wherever you want to go.
yeah.
Um, I still don't feel, and here's another thing. As an engineer, we all know this, you're always learning.
Yeah.
And even
That's
to this
definitely
day, I still feel like, I have tons to
to
learn,
learn. Yeah.
from other people here.
Mm-hmm.
And that's just super exciting to me. Like,
Yeah.
that there's still room for growth as far
Yep.
as technically speaking. I mean, we have one engineer here who's been doing just pure technical engineering work for like over 30 years. And
Wow.
he's our senior principal engineer.
Mm-hmm.
And just the fact that he's still, developing and learning and pushing innovation just shows like you can have a full career being a technical engineer. I know a lot of engineers move to management and other areas,
Mm-hmm.
which is great, and that's really cool too.
Mm-hmm.
But if you want to stay technical, it's really nice to know that you can do that all the way, through
Throughout your
your
career,
whole
yeah,
career.
definitely. Those are working, talking. I call them encyclopedias of like whatever
Oh my
niche
God,
they're
yeah,
working.
yeah,
Yeah. Um, they have some in every industry. I know. When we was with couplings, we had someone like actually most of the leadership within the chief engineer, and then we had principal technical engineers. They most of them been there for some are like 30 years then, and
right,
they're actually the company was actually trying to bring in more people, younger generation, to make sure that that knowledge doesn't go with the person once they retire,
exactly.
because you always have that fear.
Yeah, and even when so we have some people, even when they retire, you basically you're kind of still a consultant in a weird way, like that
Yeah.
if you need to call and have a question or something, and
Mm-hmm.
you're still involved in the industry because it's been your life's work.
Yeah,
And
definitely.
another thing that I want to mention that's really, I think, important to engineering, that kind of goes across all of the types of engineering industries,
Mm-hmm.
is the idea of innovation and creating something new, an invention. So you may like I found when I started working here, I was learning from others and kind of walking in their footsteps per se.
Mm-hmm. Mm-hmm.
Um, but as I got here more and more, I found that you have unique ideas And in any industry, your ideas should be explored, and that's
Mm-hmm.
what's really fulfilling in engineering. And it could be as small as choosing a new material for something that
Mm-hmm.
has never been used before, or as big as like a full design, like a fully vetted invention that you submit to the patent office. So it can really go from the smallest all the way to the biggest thing. But
Mm-hmm.
I encourage any engineer, whatever industry they're in, there's always room for innovation.
Yeah.
And if you have an idea, you should try to find, that one person at work who will listen to it,
Mm-hmm.
or maybe that one manager who's open to trying something new or
Mm-hmm.
doing something differently. Because I find that when I, try to come up with a solution to something that
Mm-hmm.
hasn't, been done before, or maybe
Mm-hmm.
hasn't been used in a certain way,
Mm-hmm.
and we try it, even if it fails, maybe
Yeah.
it doesn't work or it doesn't go through to the end product.
Mm-hmm.
Just exploring that in your own brain, that creativity, that newness, that novel idea
Mm-hmm.
is like one of the most rewarding, things that you can do as an engineer. I
It's
think I
yeah.
think any engineer should try to at least explore it a little bit in their career.
Yeah, it's a very fulfilling feeling, especially if you do actually end up solving
Hmm.
like a challenge.
Right.
It's a great feeling. You get that
It's
euphoric
it's
feeling that cannot
you
really be
really do.
replicated. Yeah, yeah,
I
I
mean,
agree.
because I find myself, there's been so many great engineers who worked here and other places before me that like you could almost make a full career on trying to be as good as them or copying their designs and trying to, recreate what they've done. And that there's nothing wrong with that. What they say is if it's not broken, why, no need to fix it.
Mm-hmm.
But at the same time, you know, innovation is how we push things forward and how we improve upon our designs, and doing things differently in a certain frameworks is always going to help your company, whatever you're doing.
Yeah,
So I'm still struggling and trying my best to include that, whether it's new way to design something, or like I said, a different material, or some little innovation. It's always something that I kind of am working
yeah,
towards.
and I think we shouldn't. I agree with you, and I think it's dangerous when we get complacent and kind of just accept things as they are and accept the old way of doing things. And I think that's why companies like Apple were so disruptive, because for a long time, I think we had ignored, or the industry had kind of stopped innovating, right? And
There
then,
you
like,
go.
when you have Apple and Steve Jobs coming in with his team, Steve Wozniak, and they just like pushing the boundaries, which
Of
kind of
course.
we are encouraged to do in university, and just pushing that boundary and trying to innovate, then kind of like it's skyrocketed. And now you look at Elon Musk, that's what he's doing now as well, pushing the boundaries of engineering,
Of
pushing
course.
what we're able to accomplish, like just
Yeah.
continuously innovating and not being satisfied. So we had
Yeah.
that's continuously doing that, and as you can see, it's very rewarding. Tesla now is like $1 billion company, Apple and Samsung, Google.
Of course.
So
And you're 100% right. It is extremely rewarding. But I think with innovation, there is an inherent risk. If innovation isn't free, right? Like
definitely,
no one
yeah.
is, no one is. I mean, some people, if they're passionate enough, they can do it on their own. But time is money, right?
Mm-hmm.
And resources, time, and investment in research and development, and having the freedom and stuff to do innovative type things is definitely a risk. I mean, it's a risk that
Mm-hmm.
a company has to take, and a lot of companies see it as an investment. But not everything you do is going to work, and that's just the nature. That's the nature of life,
Yeah.
and we are in a an economy where profits and income are what drive business, right?
Def-
We got to, even in my company, we have to please our shareholders one way or another. We have to, bottom line, we have to make some money. Um,
yeah. Yeah,
so
that's true.
that's the big debate. You want to make money, but you also want to innovate, and it costs money to innovate,
Yeah,
right?
yeah.
And it's a risk you take. It's a calculated risk.
Yeah, it's yeah. I think yeah, it's that's a good point, and I think again, you know, it's gonna have to be a balance, right? Because
Of course.
um, what is that? Bust. So I was just watching this documentary, and
Mm.
it was more so about Boston Dynamics, but just about the
Oh
fact
yeah,
that they're
robotics.
robots, right? Like the Spot, like that dog like robot that now is on the market where they sell it to like government entities and local entities, right, and cities. They just introduced one in New York, like the police department of New York actually introduced one to answer the calls, like a 911 calls.
Yep.
So I was watching this just video on YouTube, and the guys was talking about how Boston Dynamics, they're very at the forefront of innovation, but it seems like
Hmm.
they're not really trying to profit much. And it seems like there are now other copy-like companies that are kind of innovating, that are bringing out similar products to the market, way much more affordable. So, you know, where does
Yeah,
that lie?
it's definitely, that's more of the business side of things.
Mm-hmm.
And I'm definitely not an expert in business or economics, but I know enough to know that innovation definitely comes at a price. And you look at Apple and Google and the big tech companies, they've figured it out where they created a really good product to start with and innovated enough
Mm-hmm.
to be very successful and have enough money to reinvest.
Yeah.
Whereas a smaller company like Boston Dynamics or another tech types company who has big overhead. So another thing is
Yeah.
like overhead where they're building robots, they need space to pay for.
Mm-hmm.
Google and these other companies, they started out, they didn't really need, it's all computer based and cloud
Yeah.
based, so they didn't need. But
Luck.
anyway, the smaller companies, it definitely takes, it's harder. It's definitely harder to turn a profit while also pushing innovation. I think that's a
Yeah.
big challenge for startups.
Definitely. Luckily now, I think the costs have gone down, and I'm sure probably companies like Apple and Samsung, I'm sure they probably have some kind of model to see, or maybe to test what is worth pursuing and what is not. But thanks
Yeah.
to 3D design technology and 3D printing, now the it costs way more to CAD something new and fabricate it in your own lab without having to outsource it, because that's where most of the costs were, a lot of the costs were coming from.
Of course.
So
Yeah. Yeah, with that's a good point. When other technologies get developed, your own technology becomes easier to develop.
yeah.
They kind of piggyback on top of each other. And that's definitely true for manufacturing processes, like as those processes like 3D printing, additive manufacturing, all those types of advanced manufacturing has really helped with innovation in lots of other areas. So that's actually a great point. Um, and that could be a game changer in the future for startups when they try to innovate using the technology that other people have developed.
Mm-hmm. Yeah. Do you see yourself, or you don't have to answer if you're not sure. Do you see yourself staying more so on the technical, or eventually do you want to move towards management?
That's a great question. I mean, that's a question every engineer will have to face, I think, at some point in their career. And I've even seen people, who are around my level of engineering move to management
Mm-hmm.
already. And to be honest, I think I will stay technical for quite some time until I feel like I've achieved some more of the innovation stuff we've been talking about, maybe
Mm-hmm.
some more product development type work. I definitely feel like I have a lot more to contribute in the technical space. So
Mm-hmm.
I'll definitely stay technical for the foreseeable future.
Mm-hmm.
With that being said, even being technical where I am, we have the ability to run a project in a sense
Mm-hmm.
that like you can communicate, you can be the lead engineer on a project,
Mm-hmm.
so you do get some of that management. You have to coordinate with electrical engineers, RF engineers, project managers, and other
Mm-hmm.
people, and even like develop schedules and estimate costs. And so
Mm-hmm.
you get some of that management experience while also being really involved with the technical design. So I don't know how that is at other companies. Luckily, at mine, I'm kind of able to do a little bit of both and get experience with both.
Mm-hmm.
And that makes me feel confident that maybe 10 years from now, between 5 and 10 years from now, if I
Mm-hmm.
really want to, I can become a management type person, or even lead a team of engineers and be semi-technical but also managerial.
Yeah,
Um,
because I guess there is a middle line where you could be a technical manager, where you're leading a team but doing innovation,
sure. Right.
or you can do business. Yeah,
And in a small scale company and a small team, you almost have to, because
definitely.
you're
Yeah,
gonna want to
you're
wear
right.
multiple hats.
Mm-hmm.
And
You're going to need
um,
to. Yeah, yeah.
yeah, where I mean the company I'm at now, it's quite large, so it's less such like that. But I'm always looking for smaller, innovative teams and groups, companies. That's what I'm really into and passionate about. Small, agile, innovative engineering is just obviously that's the cool stuff, right? Everyone likes that.
Yeah, definitely, definitely. All right.
Um,
So I always like to, during the podcast, I try to reserve some time to ask some maybe student specific questions.
of
I
course,
I
yeah.
always like to, kind of see how I can get the podcast or the guest to maybe share information that may be valuable to students who may be who are engineering majors who may not be sure what they want to do, or maybe they are interested, or even engineering professionals who may be interested in, whatever it is that you're doing, and are wondering how can they get their foot, a foot in that industry, or
Sure.
in that niche. So what traits do you think are most important for the things that you do now?
Okay. Yeah. So, in our industry, the important traits, one is you have to be a good communicator. I mean, that's probably at most jobs, and I know that says it on most things, but you really need to be able to portray technical information well to
Mm-hmm.
different types of engineers so that they can understand it and work together.
Mm-hmm.
Because we are such a, we really rely on multifaceted engineering teams to get things done. So,
Mm-hmm.
I'm always talking to other electrical, RF, systems engineers on
Mm-hmm.
on getting projects done. So that's one thing. Another thing is, you have to have that drive and that passion and that ability to work hard. I mean, I work. You if there's a project that needs time, I don't have any problem working extra hours or overtime
Mm-hmm.
to get it done because I like it. It's really fun to me.
Yeah,
So if you have
definitely.
that passion, that drive, and that excitement about engineering, we
Mm-hmm.
look for that in someone we're going to hire.
Mm-hmm.
And I mean, if you have those two things, the communication and that drive, the technical ability is also a thing.
Yeah.
I think that's the third. That's third best after the first two.
Okay.
The drive, the communication, and then you do have to have that technical basis. Know what you're doing. You have to be able to, think outside the box and be an independent learner. I mean, those are all kind of in that third group.
Mm-hmm.
Being an independent learner is really important. Being able to figure something out on your own, and try to find a solution through research
Mm-hmm.
or through your own experience or speaking with other people
Mm-hmm.
and solving a problem is also important. So you do have to be kind of a self-starter
Yeah.
and have a good technical basis. Those are the top three things I would say in our industry that are really helpful.
Okay, so for a student, let's say I'm right now in college, right, and
Yeah.
engineering. How can I position myself, and what can I do to portray that technical aptitude that's required?
Yeah. Well, I think what I've learned so far in communicating with other engineers of different
Mm-hmm.
backgrounds, you really got to be, you got to be humble and willing to like see things from another person's perspective
Mm-hmm.
and not kind of project your perspective on them. So you really got to be a good listener, I think. So practice listening. If you're in a team at school with a group
Mm-hmm.
project, just listen to where your teammates are coming from. Their ideas may not be what you think is best, but some in real life, in engineering and in industry, that's how it is. You gotta take other people's perspectives and be pretty humble about it and learn where they're coming from and that really does help with communication, I think.
Okay. So now, for example, let's say you were recruiting, you went to UMBC right now, you're recruiting, right?
Mhm. Of course.
How, because, it doesn't matter what skills a student has or what they know, or, how technically adept they are. How, for example, you look at their resume, talk to them, like, what would you be looking for?
I would be looking for someone who, I mean, is clearly, it's very evident that they like are just they love engineering. They're into engineering.
Mm-hmm.
They've shown through maybe personal projects
Mm-hmm.
or the way they speak about their class projects
Mm-hmm.
or maybe the way they show interest in what we do at our job and
Mm-hmm.
ask certain types of very unique or interesting, engaging questions
Mm-hmm.
that are very specific to something that they're interested in. It's all about that conversation, and in that conversation, you learn like two things. You learn one, how are they with communication, and
Mm-hmm.
two, are they really like, are they passionate about engineering? Are they
Mm-hmm.
passionate about what they do every day and going to and working and stuff like that? So you can kind of gauge both of those things
Mm-hmm.
through in-person conversation. At a career fair or something like that.
Okay.
I personally I'm very interested in electrostatic speakers for my home stereo, so I kind of have that personal hobby and
Mm-hmm.
cars and stuff like that. And I've seen a lot of, talking with a lot of coworkers and colleagues and students who I went to school with,
Mm-hmm.
a lot of them had interests outside of school.
Mm-hmm.
And maybe they're not fully technical, maybe they're a little bit, in a different area, but
Mm-hmm.
that passion for something is something we definitely look for. Like
Mm-hmm.
what are you about? What are you into? What are you going to bring that's a little bit unique to the
Mm-hmm.
team or to the table that can help us, innovate and succeed. So that's kind of what we would probably look for.
I see. Definitely. That's very valuable, man. Thank you for sharing that.
Of
Other
course.
than that, what other advice would you give to any student that may be listening to this, from now that you're kind of you've gone through that, school phase, where you may be uncertain about a lot of things. What do
Of
you have?
course.
Is there
Of
anything that
course.
you could share?
I mean, the one thing I would say, or a few things I would say is first of all, just never quit, never give up. There's going to be obstacles. Just there always are going to be obstacles. A class isn't going to go well. Your girlfriend might break up with you. Something might go wrong.
Mm-hmm.
But if you keep at it and keep the light at the end of the tunnel in your brain, you will find success and it will be very rewarding. And if you have that passion, just don't quit. I know it's cliche, but it really does pay off, and hard work will pay off.
Mm-hmm.
And don't be another thing is don't be afraid to be passionate about what you like. Being yourself and
Mm-hmm.
being passionate about whatever you like is completely okay.
Mm-hmm.
And in fact, it'll be rewarded. People will recognize it, and they will and maybe it's not what they like, but they will
Mm-hmm.
recognize someone who's passionate about something. And it's very inspiring to see, and people will really receive it well in life. I think that helps in personal life and your career. Just so be yourself, be passionate about whatever you like,
Mm-hmm.
and don't quit. And I think if you do those things, you'll be completely successful and find some really really fun stuff to do in your career.
Alrighty, man. Awesome. Sounds like wise advice.
I guess so.
So how can is there a way that people can reach out to you online, or if maybe if someone has
Yeah,
questions or like to connect with you?
sure. Yeah, I mean, I have LinkedIn,
Mm-hmm.
Edwin Quinn on LinkedIn. That's probably the easiest way. You can email
Mm-hmm.
me at, I guess, should I give my school email or my personal?
It's up to
I
you.
can, yeah,
You don't
sure.
have to.
You can email me directly if you have a question or literally any type of interesting engineering project or anything really at
Okay.
edwinaquinn@gmail.com. So that's
Okay.
EDWINAQUINN@gmail.com. No spaces or dots.
All right.
Um,
Awesome. I'm gonna
and you
go
can
ahead.
find me there.
I'll include it in the podcast, in the episode
Awesome.
description as well, so people can easily connect with you on LinkedIn, and
Sweet.
reach
Yeah.
out. Again, this was I really had a good time, having this discussion with you. Thank you for putting your time and sharing all this valuable
Of course.
information. Really appreciate it.
Yeah. Yeah. I was super excited when you reached out. I think that we don't have enough, online resources and podcasts about engineering
Hmm.
right now. So I was really inspired by you coming up with this idea on your own and putting yourself out there in this manner. So I was really glad you reached out to have a discussion. So thank you for having me.
Definitely. Well, there you have it, folks. I hope you enjoyed this conversation with Edwin. I definitely had a blast, talking with him, and I hope it was valuable for you as well. And as always, if this is valuable, make sure you share it and you're spreading it out there. I think it's going to benefit a lot of people, and um, I'm definitely looking forward to it. All right.